So it was in our last video when we talked about horizontal asymptotes. We said when you had a polynomial on top and a polynomial on bottom, where the degree of the top is smaller than the degree of the bottom, then you have a horizontal asymptote at y equals 0. When you have a rational function with polynomial on top, polynomial on bottom, and the degrees of the top and the bottom are the same, then you have a horizontal asymptote at y equals, you have to take the ratio of the leading coefficients. And finally, we said when the degree of the top is bigger than the degree of the bottom, you're not going to have a horizontal asymptote. So in that third case, sometimes when you don't have a horizontal asymptote, sometimes you have something called a slant asymptote, possibly. We haven't talked about slant asymptotes, so we want to introduce them here. So what is a slant asymptote? So sometimes it's also called an oblique asymptote. You hear it called an oblique asymptote. So slant asymptote, oblique asymptote is the same thing, same word, same meaning. So we say that the line y equals mx plus b is a slant or an oblique asymptote of the function f if f of x approaches y equals mx plus b as x goes to either positive infinity or goes to negative infinity. So let's show what that means exactly. Here's my x-axis and my y-axis. I'm going to take this y equals mx plus b. I'm going to make that red if I can. So that'll be a line, maybe like this, depending on the slope is positive or negative. No, that's not your function. Your function could be doing something like maybe this. So maybe it's getting close there on the right side. So as you go to the right, the function approaches this diagonal line. Yeah. Or it could do something else. I don't know, it could do something like this. Your function could maybe do something like this. Oops. It gets really close, but never touches that slant asymptote. Yeah, there are all kinds of things that can happen. I'll just give one more example. I don't want to get too much into drawing pictures here. And have something like this, for example. So those blue bits of graph, they're going to approach that red dotted line, but never touch it. That would be called a slant asymptote. So that line would be y equals mx plus b, the red line. Okay. Now, how do you know if you have a slant asymptote when you're dealing with these? We'll figure that out. Finding oblique asymptotes, or I'll call them slant. Slant's a better word than oblique. For rational functions. So if you have a rational function, it's possible that you may have a slant asymptote if you do not have a horizontal. It's possible. So let's say let R be a rational function. R of x equals, let's say, P of x on top, Q of x on bottom. So P of x is the polynomial on top, Q of x is the polynomial on bottom, where P and Q are polynomials, where P of x and Q of x are polynomials. Okay, so we just have a rational function so far. If the degree of p of x is equal to the degree of q of x plus 1, what that's saying is the degree of p of x is 1 more than the degree of q of x, right? It's 1 more than the degree of q of x. So that means on top the degree is larger by just 1, then R has a slant asymptote. It's a slant asymptote. Y equals q of x, where I shouldn't have q of x here. Let me write it as something else. Y equals, let's write it as y equals mx plus b, mx plus b. Where mx plus b is the quotient. The quotient of p of x divided by q of x. Yeah, so basically we're going to have to do like a long division where we take the top polynomial, divide it by the bottom polynomial, and the quotient of that is going to be this linear y equals mx plus b part. And that's going to give us our slant asymptote. So that only happens when the degree of the top is exactly 1 more than the degree of the bottom. So let's do some examples of that. Examples. Let's say I have, r of x equals x squared plus 2x over x minus 1. So we know in this rational function, there's no horizontal asymptote, right? Because the degree of the top is bigger than the degree of the bottom. But there is a slant asymptote, right? Because it's exactly 1 more than the bottom. If you look at the bottom, the degree is 1, the top is degree 2. So the top has degree 2, the bottom has degree 1. Top is 1 more degree than the bottom. So there's a slant asymptote. So what we're going to do, we're going to take the top polynomial, x squared plus 2x plus 0. We're going to put a constant of 0 in the end. And we're going to divide the bottom polynomial into it, x minus 1. So how does that work out? Well, let's make this x out front here yellow. The question is, what times that yellow x will give you that red x squared right there? Well, x. And we're going to put an x up top. An x up top. In the x column, now we're going to take that yellow x times that yellow x. We're going to get x squared. And then we're going to take that x times that minus 1. We're going to get minus x. And then we're going to subtract. X squared minus yellow x squared is 0. Red 2x minus a negative x is going to give us a positive 3x. Okay, then we're going to bring down this 0 here. Okay, now I'm going to ask the question, what times this yellow x out front is going to give me this 3x? This 3x. Well, it's going to be a positive 3. So I'm going to put a positive 3 up top in the constant column. So I'm going to take 3 times x is 3x. I'm going to take 3 times negative 1 is negative 3. And I'm going to subtract. Okay, so 3x minus yellow 3x is 0. And then we have 0 minus negative 3 is going to be the same thing as positive 3 here. And this is your remainder right here. That's called the remainder. So when you're doing rational functions, you're not going to get a remainder of 0, like with polynomial division. You're not going to get a remainder of 0, like with polynomial division. You're going to have a remainder. So what we're going to do, we're going to rewrite this as x plus 3. Okay, so you take that yellow up top, which is called the quotient right there. And then we're going to write plus, and then you're going to rewrite your remainder, this one right here that we circled at the bottom. That's a positive 3, so I'm going to write plus 3. And I'm going to take that, I'm going to rewrite it over my divisor. My divisor here was x minus 1. That's basically what we've done. We've simplified our rational function. We've just rewritten it. This is the same function right here, x plus 3 plus 3 over x minus 1. This is the same function as this one back here. It's only simplified. It's in a simpler form. Now, what is the slant asymptote? The slant asymptote is going to be this part right here. That's going to be my y equals mx plus b part. It's going to be y equals x plus 3. That's the slant asymptote right there. So probably I should have wrote that right underneath where it says slant asymptote. Maybe I should have moved my my long division to the side. So next time I'll do my long division on the side. It's okay. I'll do another example here. So here's another rational function, 2x cubed plus 2x plus 3 all over x squared minus 1. So automatically I can see that on top I have a degree 3. On bottom I have degree 2. So since the top's degree is bigger than the bottom's degree, we're not going to have a horizontal asymptote. Since the top is exactly one more than the bottom's degree, we're definitely going to have a slant asymptote. So I'll do slant asymptote. And this time I'm going to do my long division off to the side where I should be doing it. Okay, so I'm going to take my top, which here I'm going to circle in red, 2x cubed plus 0x squared plus 2x plus 3. Notice that in the square place, there was no square term, so we just put a 0x squared there. And let's see, beneath that, I'm going to put this x squared minus 1. We're going to put x squared plus 0x minus 1. Okay? There wasn't an x term in that blue denominator, so I just put a 0x. Okay, so now I'm going to ask the question, what times this yellow x squared out front is going to give me 2x cubed? Well, 2x. So I'm going to put a 2x up above in the x column. So now I'm going to take 2x and multiply it through the blue. I'm going to have, let's do it. 2x times x squared is 2x cubed. 2x times 0x is going to be 0x squared. And 2x times negative 1 is going to be minus 2x. Then now we're going to subtract that from all our red stuff above it. So the 2x cubed minus the yellow 2x cubed is going to cancel. The 0x squared minus the 0x squared doesn't contribute anything. But when I do 2x minus a negative 2x, it's going to give me a 4x. And then I have a plus 3. Now this 4x plus 3 here is going to be my remainder. It's going to be my remainder right here. And the reason why it's my remainder is because look at the power on the 4x plus 3. The largest power is a power of 1. That power is smaller than what we're dividing by, x squared power, right? The x squared power. Okay, so I'm done my long division. So what I'm going to do here, I'm going to rewrite this rational function. This is going to be equal to equal to. So first I'm going to write my quotient up top, 2x, and then I'm going to write plus, I'm going to put my remainder, which is 4x plus 3, over top of my divisor, which here was x squared minus 1. So this is our function rewritten. It's rewritten as 2x plus the remainder, 4x plus 3 over x squared minus 1. So this yellow part right here, that's called the linear part. That's going to be your slant asymptote. So we have a slant asymptote at y equals 2x.